Uh, Hello everyone, welcome. And now we are going ahead with the multi-replication. So yes, any questions or query from the previous session anybody wants to discuss?
So I have a query like what is the difference between distributed cache and global cache? Like any input from that?
I so don't know exactly.
Like distributed
Yes.
cache is basically used by every server, right? Like every server will its have own copy, right? Then
Yeah, I think so. So it will be like the same
and
what we think about distributed, right? So, but if it's a
about
global, it might be at a single place, so and
and
all,
everybody will
yeah, all services can actually access that cache. Okay, so
also only
thinking a layman's term, okay.
no same thing. Like distributed is also used by like everybody can have access to that
No, well, okay,
distributed.
there is slightly difference because in a distributed, it might be, see, the global will be a complete one. So the same global, if you actually divide into different chunks, and then you distribute. So the way you do a sharding, right?
Okay.
So that may be one way of looking at it.
But then
That is what I think.
global cache size will increase a lot, right? Because I mean, there is only one limited space, right? And everybody is trying to cache the things over there, right?
So it depends on your use case. If your use case is not going to go, your cache is not going to increase to that extent, and it's possible to fit in a machine,
Okay,
okay,
then
or
use
maybe in a
global.
couple of machines. So you may have a cluster of machines in there also. So you can scale there also. It
But
again
that's not
depends on what you want to.
fault tolerant, right? If because global cache is only one. If that fails, then like again
But you will have a
you'll have
replication there also. So the same principle, if you want to make it fault tolerant, you'll have to have replications and all that stuff again. And then again, maybe a leader based. I don't know.
correct, yeah.
Yeah.
So yeah, so one of the guys it seems asked this question here, distribution and global cache. And the solution here is that one of them was Terracotta, example he has given. It runs on an independent server master, but also it has its own client running on all the different client nodes. So whenever client asks for data, it asks from the local Terracotta client. Now, if there is an update in the shopping cart, suppose then that node client updates its local Terracotta client, which in turn updates the master, which in turn updates all the other client nodes. So it's responsibility of the Terracotta to make sure the data is in sync on all of the nodes and master. Of course, if any client dies and comes back up, then it picks up initial data from the master. If data asked is not there on the local node, it asks the master for it and then keeps the data locally. Other solution like Redis and Memcache keeps the data on the master node, and client always goes to the master node to ask the data. Drawback is that serialization and deserialization happen with each request. Okay. Interesting, but it's not told which one is which.
So
Yeah,
it is
that's
something
what
like
I'm.
the way Chubby also has, right? So you have clients for Chubby, and they have a clients will also have a cache, and so the cache is only invalidated if there is a write in the master. Okay, so if it is not, then they always keep on accessing the cache. And if there is a change by some other client which makes into master, so master knows where its cache is distributed, so it keeps a
And
track of everything. Yeah.
that is communicated to rest of the client, right?
Yeah. So they have that heartbeats, always going back and forth. And then based on every time, whenever the request comes in, it has to go through the heartbeat. So you will never miss, so you will never get a stale data. So that is what the whole thing is. So that is a distributed cache.
So Redis is same only, right? Redis, Memcache, all these are distributed cache only, right? The second one is the distributed cache is talking about. Like if you drag it, right?
Yeah.
The Redis and Memcache. These are all distributed only, right?
Yeah, but I think you can configure it in different ways. You can make it distributed, or maybe you can make it global. So global means everything will be at a single place.
Correct. So like in distributed and global, in both of them, like all the servers can like access, right? That is what I'm. There is no difference in that. Only difference like what is it? Individual copy will have in distributed, right? Which is not in the case of a global. What I think.
Individual copy will be in the
Like
distributed.
every server, yeah, every server will have individual copy of the cache, which is in distributed, but not in the case of what you say. Because let's say a request call A, right, goes to server one, right? Let's say first time it is cache match, right? But second time if the same request goes to server B, so it will check in the distributed cache, right? That has this already been accessed before or not. If it is, then it will direct that request to another server, right? So that is what I'm thinking. Like in distributed, each one of them will have its own copy, but in global there will be only one, and every server will have access to it.
Well, so I
Like
was thinking about distributed to be sharded, because I don't want all the clients to go to each and every server like a leader-based way. So a
definitely it will be
particular thing
sharded.
is if it is sharded, so you will always need to all of the clients to go to that particular server and its replication. Don't go to all of them.
Yeah, that's right. Like global doesn't make more sense here. I mean, you can make the second level cache there if like some frequently accessed elements are there. But there is no point making because that much memory and that much space it will be taking if you are having multiple copies of this local cache and then a replication of that in the global cache. So I guess what Santosh is saying, as per the shard, that sharding mapping will be there in the load balancer or somewhere, and as per that, your request will get directed to the individual
Server.
distributed.
Okay.
Yeah.
Yeah, that's
And
right.
application cache is a normal cache, right? The cache which is present at the DB side, or the server side, right?
Yeah.
There is application cache.
Application cache is there for every server. That. Yeah. That is.
So is it at the server or at the DB level? I mean, I get confused. Cache is at the DB level also, right? Just
Yes,
before the
so two kind of thing, like at load balancer level also I have seen the cache. So at each at each layer application or DB or middle layer like load balancer and those things, so you can put cache. So this kind of architecture, if you see, like it's there always. Cache
So
to me. Yeah.
application cache is what? Is it at the server level or at the DB level? Like, or
So
there is
DB
different.
level they have different cache. So in the DB2 like SQL and all, they have the cache. Um, and they have written the files, the data in the disk, but they have the cache. They make like when you do query, they directly don't go in the file system and then from there they seek the pointers and get it.
Discretes.
Yeah. So they have some, I guess, cache there too. So I remember yeah, in Hibernate there is a cache level 1, cache level 2. So
L1, L2 cache.
yes, L1, L2 cache. Yeah. So that's why they make it for more performance. For more performant. Yeah.
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 So the way this Modi sir has also shared some Medium article. It shows about different caches. You can have an application server, or you can have a cache at the DB, or you can have in middle. So that will be a global. So I think that article also explains to some extent in a high level what are the definitions of the global or distributed cache. Yeah.
Okay, we'll check it.
Yeah, I think it's good to go through that article when we have time. Yeah, sure.
That well diagram is also good.
Yeah.
Yeah, we can start.
Okay, cool discussion. Even I will also be going with that. Right. So resuming back. So just a quick recap. We were talking about the multi-leader, right? We spoke about scenarios and how it is different from the single leader operation. Okay, right. Moving ahead. Then clients with offline operation. Another situation in which multi-leader replication is appropriate is if you have an application that needs to continue to work while it is disconnected from the internet. Interesting. For example, consider the just let me pick up so that
Some kind of background noise, I guess it's there. If everybody can mute except the reader.
I think it's my fan. I think.
Oh, okay. Oh, sorry.
Yeah,
Maybe.
it's got a little hotter, so I've increased the
Yeah,
fan.
his laptop fan actually does that sound sometimes. Yeah, it's okay.
That also. Yeah, but I'll try to keep it discreet. Move it a little.
It's okay. Yeah, no worries. Yeah.
Yeah, it's okay.
Yeah. Okay, cool. So consider the example that the calendar apps on your mobile phone, okay, your laptop and other devices, you need to be able to see your meetings, make a read requests, and enter new meetings, make write requests at any time, regardless of whether your device currently has internet connection. If you make any changes while you're offline, they need to be synced with the server and your other devices when the device is next online. In this case, every device has a local database that acts as a leader. Okay, it accepts the write request, and there is a asynchronous multi-leader replication processing between the replicas of your calendar on all of your devices. The replication lag may be hours or even days, depending on when you have internet access available. Okay. From an architecture point of view, the setup is essentially the same as multi-leader replication between data centers. Taken to the extreme, each device is a data center, and the network connection between them is an extremely unreliable. As the rich history of broken calendar sync implementation demonstrates, multi-leader replication is a tricky thing to get right. There are tools that aim to make this kind of multi-leader configuration easier. For example, CouchDB is designed for this mode of operation. So, okay. So this particular problem statement is more with regards to devices or entities which are down and they want to get synchronized. So in case of phone app, the example given is that there's a calendar app on the mobile phone, laptop. If something goes down on your mobile phone, I enter the event, but it's not synced on my laptop and other device. So what it is trying to tell is it kind of makes the local database within the phone as a leader. And then there's asynchronous communication sync between the replicas of your calendar and all of your other devices. This is another use case of multi-leader operation.
So this can be a synonym to one of the Dropbox also, right? So Dropbox also, if you have an app, a client,
yes,
and if you have in different of your devices, so that can also be almost similar to the example what he's stating over here, isn't it?
What I'm trying to figure out is why could this not be solved by a single leader follower operation? How is this getting done by a multi-leader application?
So I totally didn't get this one. If your device is offline and you have only one local database, you don't have a internet connection, how it is replicating?
No, it's saying that the local database becomes like a leader within the phone.
Yeah. Yes.
And, yeah, and it's like as good as it is down right now. So that's what it is saying. So the use case is that you'll be able to see the meetings you make the read and enter new meetings of any time, regardless whether you have internet connection. If you make any changes while you're offline, okay, then they need to be synced with the server and other devices when the device is next online.
Yeah. So local database per device that acts as a leader. So all devices leader. Database will be leaders. Yeah.
But when you will come online, then they will do replication, right?
Then they will sync up. Yeah.
Yeah. Now I'm sync up. Sorry. Yeah.
Yep.
So in case of single leader, the sync up won't happen then, because this would be more like a follower in that event.
If it's a single leader, you mean to say if it's a single device.
Yeah, I'm just trying to understand the example here when it says that this is an example of multi-leader. I get that this is acting like a leader and it is trying to propagate the other data center or the other devices about the change. And I'm guessing that when it says other devices, it's like they are leaders within their own local storage, maybe, where it is getting replicated. But in a single leader model, I'm assuming this would be treated like a follower, right? The phone device. And hence, if we are offline, any change is made over here, it won't get replicated because it is part of the follower, I guess.
Yeah.
It's not only it cannot replicate, but you cannot change it too, because every write has to go through that leader, right? If your
Leader, okay.
disconnect
Okay.
leader, you cannot even make a write.
That's a good point. Yeah.
Okay. But what if my device becomes a leader in that case, and the other devices become the follower?
Yeah, then you won't be able to write to the other devices.
No, my device, like this phone device, is the leader. The local database is the leader, and the other devices, like the laptop, is the follower. So when this is down, then this will have to come up and then replicate, I guess.
In that case, I think that it treats as the failed leader, right? Because if your device is the leader, and that means all the device may not able to see your device and think that, okay, the leader is dead, so they go ahead and elect the new leader.
Yeah.
Right. Got it. Yeah, makes sense now.
Yeah. So the data in that leader will always be the benchmark data. So if in this case, it's not that case. So all the data on each of these devices is equally important. In that it is not. So follower data is not important. The leader data is more important. If you have to give some sort of priority, to just for ordering and all that stuff. Yeah.
Yeah, I was thinking from single leader point of view, where this would be the nominated leader, which has gone down. But then I think so, Nikolai pointed out that there's always an election process where the new leader gets elected, because there would be some kind of heartbeat or some kind of way by identifying that the leader is not accessible after a certain time or threshold. So it goes and promotes another leader. So the laptop might become the new leader in this case.
Yeah. But if you look at this use case, it might be so like the laptop what you're using, it might be off and disconnected for a very long time, or maybe the phone is disconnected for a very long time. Still, when it comes up, the data is valid, and it still has to sync up with the other devices.
I mean, that's why the multi-leader kind of works here, because they all are leaders in a way, device to device, because we are making a change in that.
Yeah, so I missed the study sessions. So how, like, if we have multiple leader, so who will get the priority? Like, whose data will be the most important one? If we have multi-leader,
All of them.
all of them. Okay.
Yeah. Then you'll have to do some syncing up with resolve the conflicts and all that.
Yeah.
Okay.
There's a diagram here for that part. Sorry.
So the resolve configuration, it has to be done two ways. Like, one is manual, and the other is there any competitive product there which does?
There are, isn't it? So I think
LWW for Cassandra we have, right? Last write wins. Then you have client side resolution.
Yeah, so you have that CRDT also. Yeah, that is right.
CRDT is also there. Yeah, data
but the Cassandra again goes to that leader as well, no? So we all get confused about it. Yeah. So that is what Praveen was talking yesterday, isn't it? Yeah.
Okay.
So we have that data structure like CRDTs and all that who take care of it. So if you want to do that automatic conflict resolution, but that is still expensive and it might not be very accurate in some instances. So yeah, but there will be different ways, and it all depends on your implementation.
Got it. Yeah, thank you.
Cool. So, right. So I hope everybody got that part. An example is CouchDB given over here for that case. Alrighty, moving ahead. Collaborative editing. Yep, this is our Dropbox example.
CouchDB is multi-leader, right?
Yes.
And where do we use
give
this?
you a very specific example also, that whenever an offline operation happens, the other guy would get up.
I think
Sorry,
Shashank is
go ahead,
asking
Shashank.
what is the application of CouchDB, isn't it?
Correct. Yeah, because I've seen in my industry CouchDB is used, so I have to check. I'll check it then.
Google it, yeah. Eventually, it's a DB, needless to say, but yeah, type of database.
I just want to know like what kind of multi-leader are you? I mean, yeah, I'll check the use case and update it. Or if anyone knows like
it's a
when
clustered
to use
database. It's a clustered database that allows you to run a single logical database server on any number of server or VMs. It's a NoSQL database, by the way. Implemented in Erlang. Wow.
Document database.
It stores JSON data also. Sorry, go ahead.
No, I was just saying document database.
Document DB, like Mongo is also document DB.
Mongo. In that sense.
So do we use CouchDB as a cache also?
So here's the interesting part, guys. JavaScript, it uses JSON to store data, and JavaScript as its query language using MapReduce and HTTP for an API. This is cool.
What is that about, Mutsa?
The CouchDB, Apache CouchDB. I'm just looking it up on Google. So this is what I found about CouchDB, that it's a NoSQL document-based database. And interesting thing which I was not aware is that it uses JSON to store the data and JavaScript as its query language. So the querying is actually through JavaScript using MapReduce and HTTP as for an API. Sorry, you guys were saying something. I kind of interrupted.
No, I think Uday said it's used in, it's like the document DB, isn't it? Yeah.
So is it used as a cache also? Like Redis is a distributed cache. So do we use this CouchDB also as a cache?
I don't think so.
It's
because
not, right?
yeah, because then here they have appended DB, so I think it's not meant for that.
Okay then.
Like CouchDB, CockroachDB, like yeah. So I guess it's like Mongo.
Mongo, yeah, maybe. Yeah, it's like a Mongo definitely, but I'll have to check it like whether it's used as
Yeah.
can be cache or not. Oh, yeah, go ahead.
Yep. Cool. So yeah, collaborative editing. Real-time collaborative editing application allows several people to edit a document simultaneously. For example, Etherpad and Google Docs allow multiple people to concurrently edit a text document or a spreadsheet. The algorithm is briefly discussed on 174. So we'll see that. We don't usually think of collaborative editing as a database replication problem, but it has a lot in common with the previously mentioned offline editing. I think Santosh, that's what you were saying. Same thing as mentioned here. When one user edits the document, the changes are instantly applied to the local replica, the state of the document in their web browser or the client application, and asynchronously replicated to the server, any other users who are editing the same document. If you want to guarantee that there will be no editing conflicts, the application must obtain a lock on the document before a user can edit it. If another user wants to edit the same document, they first have to wait until the first user has committed their changes and released the lock. This collaboration model is equivalent to a single leader replication with the transactions on the leader. However, for faster collaboration, you may want to make the unit of change very small, like single keystroke, and avoid locking. This approach allows multiple users to edit simultaneously, but also brings about the challenges of the multi-leader application, including the conflict resolution. So I guess everybody must be getting this since we talked about in this example. The same is happening here, that someone is editing and asynchronously those changes are being reflected. So locally, it is stored in the machine or the device, and those changes are, depending on the synchronization available, it will push the data to the main server.
So,
Yeah, go ahead.
yeah, so basically the single keystroke, like if you want to make that that unit very small, how we can avoid the locking there? Like I can also write, you can also write, but I can see like your visual representation, like you are writing it. Is this what it's saying, or
So you make your unit of writing so small, so it is an atomic writing, so you don't need a lock. So it will be, whenever you're writing, it will be, you only are writing. It will be very small, so you're not going to, consume anyone's bandwidth. Yeah. But then, yeah, as you say, but you still have that other issues of conflict resolution, like we have that for a multi-leader replication.
So
one thing, yeah, good.
I was about to say, actually, basically, there are two ways to do the multi-master application for the collaborative editing, right? One is called operational transformation. Other one is CRDT, conflict-free data types. You can read about that. These are the two main ways actually people do this collaborative editing.
So let's say one word is the right. I'm also editing, and some other guy is also editing the same word. So what will be the final result?
So basically, it has to merge the conflicts, right? Because same word, it appears in two browsers, right? You're editing in one browser, you change he to he or something, right? I'm going to change from he to she, right? Now there is a conflict.
Yes. Correct.
So it has so that has to be presented to the user. That's I believe. I have to also research on that. But actually, the algorithm they use is called operational transformation, and there are some data structures also, actually conflict-free data structures that somehow automatically resolves these conflicts.
No, but like, what will be the final? Like, because he has updated the last, so that will win, or I
don't think actually it will automatically solve it either. I think it has to be presented to the user, both users or last user who edited. This is the incoming
manual conflict kind of resolution,
exactly.
right?
Yeah.
Yeah, it's difficult, because you don't never know which is going to win. So you cannot say this is the right order, right? It all depends on the implementation and use case of that particular application.
Also think about, right, actually I made a change, suddenly on the screen something else is showing up because the other person changed it, right? Because then what happened to my right? There is a lot of confusion how they are handling that. Yeah.
No, I think manually makes sense only. Like both of the users will discuss among that. This is the correct order, right? I don't think your system will take care of that.
Yeah, Git doing is something three-way merge or something, right? Something similar. Or
no.
So I guess that's why like they are making the unit of change very small, like one keystroke. If I did just write one letter, you are able to see that, and then like manually, visually, you can see like somebody else is editing.
Yep.
Like generally we see this in our Google Doc.
Yes.
Not the whole cell, like the one letter cell, not cell. I mean one letter thing.
Difference or whatever.
Yeah.
So what happened when they do one inserting, the other one deleting, and let's say it not happened it happened at the same time, but because of network delay, so we don't know, what happened first, and how is it gonna display on the screen?
Yeah, I would say it all depends on what you are designing your app, which has to be, maybe it's the timestamp or any sort of specific order based on the user priority, something like that. So it's totally based on the application of what you're trying to design and implement. You can do it anyway, or worst case will be like manual merge, right?
Manual?
Yeah, you present all the differences, whatever you have, to each user, and then the user can select and resolve the conflicts. But that will be partly automated and partly manual merging.
But there seems like a causality in here, right? Because you don't know what happened first. Was like, insert one single character happen first, or delete, a single character happen first.
Yeah. Yeah, so I guess the timestamp thing what Santosh recommended, that is going to help in case of you have valid point. If there is a network delay, obviously a single unit also can make a difference. Like if we are not holding the lock and we are saying like our unit is very, very small, like a single keystroke, in that case too, if network delay is there, obviously that other person doesn't know, like somebody else has changed it. So in that case, like some timestamp server is monitoring that and automatically it will do. Because manually, I also don't know. I think, okay, I have written it. That guy is thinking, okay, he has written it correctly. So how manual is going to help here?
Manual, like both the person will decide whether that's correct. It should be overwritten or not, right?
No,
Yeah.
but I don't know like whether you are writing it or not. If I know you are writing, then I'm fine. But if I am confident, okay, I'm not seeing any changes from you, so I'm thinking, okay, I have written it and I just left it.
But
So in that,
those differences it will show maybe.
Correct. Google Docs will be
Yeah.
will be given access to limited. I mean, the users to whom only you'll give the Google Doc, right, to edit, or is it like?
No, you have anonymous changes also, right? I think anybody.
I've seen anonymous also. Yes.
I think they have some upper limit, but still, even if there are two users, you have to resolve the conflicts. I think these examples are like that only. What you see on the screen.
So the example which I'm seeing here, very basic example they have given. There's a process A and B, like multiple editing happening here. ABC is here. The ABC guy says, okay, delete the 012, the 0 second index. Position 2 has to be deleted, so it should becomes AB. Parallelly, this guy says that insert D, so it is inserting D. Now this guy gets the D because the insert operation happened. So this is consistent, DAB. But this becomes inconsistent because when it says delete of 2, it ends up removing B instead of the C, and this is the incorrect behavior. And not going too much deep, what they are saying here in terms of operational transformation is that same approach, ABC, this deleted, this became AB, and this inserted D in the 0th, this became D. Again, this is consistent, DAB, because D got inserted first. But here, directly, rather than deleting 2, there is a process that identifies and there the operational transformation happens, wherein it would identify that the deletion is not on 2, it's on 3, because we have a 0 added over here. So there's an element already added. So delete 3 will happen. So that way it will make sure that C would go, not B. That's the very, very high level, I guess, explanation that we see here.
Very good.
So OT's algorithm or what, which keeps track of index, something like that.
So it goes something like this. So instead of going by the index, you generally assign let's say you assign some index to every letter. ABC, let's say A is 0, B is 1, C is 2. Even if it is C is 2, even if you insert D will become 4. So you will pass down that ID rather than the length or something like that. So instead of passing in delete of 2, you will pass that delete that index rather than that. Yeah, delete index of that. So even if it has already been deleted, you will know that, I mean, you will ensure that every letter has a distinct ID.
Yeah, but now when you are
But after inserting, let's say initially you keep track of A was at 0, B was at 1, and C was at 2, right? Now you inserted D, correct? And they deleted at second index, there was some other element, right? Which
No. That's why I'm not saying index. Every letter has a different index. I mean, that is different from the index at which it is occurring. ID. Every letter has an ID. So if you have written ABC, let's say 0, 1, 2 itself, now you have inserted D. Now D will not become 0. It may become 0.1 or 4 or something. Something a distinct ID. You will send that ID rather than the length or index in the string, because index can vary because of the operations as such.
So it need not be contiguous, basically, right? Any random.
Yeah, it need not be contiguous.
Oh,
you will pass down that ID, and you will chain that operation to delete of that ID or insert of that ID.
Yeah, Nick also saying that. Okay.
Yeah, one way to achieve unique ID. Yeah, we can have we can use double value as an index. Yeah, not an integer value, but a double value, and we can produce new ID based on left ID and right ID. Yeah, and so initially when there is nothing, we have just one as ID for the end symbol, yeah, for the return caret. Yeah, and when we insert something, we can, okay, this is between 0 and 1. Yeah, it will be 0.5. Yeah, and set. We can divide. And it will help us to produce unique ID. Yeah.
But what Uday is saying, that point is also, I don't think, correct, right? Because initially the index of B was 2, right? Which was to be deleted. But will this change or what? ID will keep on changing or what? Because now using OT, he is deleting 3 at third index B is there. But at initial stage ABC, B was having the index of 2, right?
Yeah. But when we delete, we just mark.
C has the index 2.
I mean,
the
0.
C that
Let's
has
say
index 2. 0, 1, 2. 0 base 2.
Okay. Let's say 0. Okay, 0 base 2. 0, 2. C has to be deleted.
Yeah, what Nick was saying.
Yeah, when we want to delete something, yeah, we can just mark for deletion, yeah, like tombstone, put a tombstone and something like this. We do not need to delete.
Okay. Yeah, so we need to go through this document, to understand it more. But on a high level, yeah, what Uday and Nick are saying, both actually have different ways of addressing this issue, right?
Yep. But I'm not getting, like, at 2 C was, I mean, initially the index of C was 2, right? If it is 0, now they're telling delete 3. So how did that index change then?
See, as per Uday, what he's saying, it's not index based, it's all ID based.
ID based only. ID, how did the ID change? Initially the ID of C was 2, correct? Or
ID of C is not going to change. He is going to add a D. So D will have a different ID now.
Correct. Then del 3, del 3, how C is being deleted, right? C shouldn't be deleted, right?
No, this figure what is being shown here is not the same what maybe Uday is saying. This might be a different way of addressing it. That is what I think. I
Yeah,
didn't really go in details about what it is written there.
yeah, it's transforming, I guess, index there. That's why it's written del 2 to del 3.
Del 3, yeah, that is what
Yeah,
is
after
happening.
transformation, they are changing it, the index. Yeah, we should go through this once for sure, because collaborating editing is the like very interview best question. Everyone try to ask this.
Fortunately, with these guys, haven't really shared much. They just stated that high level this thing happens, and then solutions they have mentioned about WebSocket at the end. They say that WebSockets is something that can make things work in such a scenario. I'm not exactly sure how.
Yeah, because actually your data is flowing both sides, right? You are editing, the other person's edits are also coming into your browser, right?
Yeah.
Both the communication is both side flowing. That's why.
So therefore, WebSocket is required. Yeah.
So in normal HTTP, only from client to server you can send, right? The other way around.
No, actually, so in a regular way, you send a request, you get a response. Then your connection is pretty much done, right? For the next request, you either you reuse an existing open connection, or basically it's kind of new only. But here actually it's keep on going, right? Actually, you keep on editing, the other person keep on changing from the other side. Data has to flow for this. Actually, it is not one request you get a response, right?
Okay, so what I can make the not conclusion, but some kind of thinking. If you are having a shared system or a shared system, we need WebSockets. Like in the Messenger too, I am writing and you are seeing it. You are writing and I am like able to get that. So is this what my correct? Like am I thinking the correct way or like?
So WebSockets versus the other technologies, right? You can achieve the same using the long pole also. Long pole is another way. Actually, you make a request to the server. Actually, a server will keep that connection open. After some time, you will get a response. After you get a response, you again create one more open connection with the server. That is long pole. Here, actually, you open a WebSocket, right? That is already kept open actually. And if the data is flowing in one direction, there is another technology called SSE, server send events. Based on your use case, any of these technologies can work.
So in long polling, there won't be empty response, right? Only when server has a response, then only you'll send it, right?
Yeah, it's like actually, okay, I'm gonna keep this line open for you for some time. That is what it is doing, right? When you have
correct, waste of the calls won't be there in case of long polling, right?
Yeah. So basically, yeah, you are waiting for a long time. Actually, if server has anything to tell you, it will respond to that in that long poll. Then the connection is closed. For the next piece of information, you have to again open it.
Initiate it, yes.
But actually, WebSockets, it's already always open actually.
Once you initiate, next time we don't need to do, right? Like,
yeah, exactly. Yeah, it is open. But the other problems with WebSockets, and WebSockets historically don't work well with the load balancers and all. Actually, you can read about that. So that is one challenge. I think now it's everybody is supporting that. Earlier, I used WebSockets. I had a lot of troubles actually getting it work. So I ended up using the server send events. That is another technology.
SSE.
Yeah.
So with WebSocket, why you still need to go through the load balancer?
Because actually your server connections actually going through a server has a load balancer in front of that, right?
Yeah, but you don't connect to the load balancer. You connect to the
No.
server, right?
Socket manager. There's a WebSocket manager, I guess.
Yeah, but actually, initially that connection comes through that, right?
Load balancer.
Yeah.
Yeah, it's only initially, but then it gets the IP address. Then from there, from that point, the client connects directly to the server.
Yeah, that's fine. Mhm. Yeah, actually, you can listen about that. Actually, there is a famous video from this Netflix guys. Actually, they are explaining their problems with WebSockets and load balancers and all. Actually, I forgot the details.
Yep. Cool. So this is also good read, right? Yeah.
Yeah, this paper looks like a good one.
And the font size is also big, so it might be easy. Right. Yeah, it's only 5 pages. So
The other thing was CRDT. You can also search about that. That is another way to solve the same problem.
okay.
Yes, CRDT is discussed in DDI also.
Oh,
Oh, really? But it's a very small part, I think, right?
Very small it is here, just a touch base here.
Mm-hmm. So about what Eric is saying, that there might be some better, more document on it. Yeah. More information. Yeah, sure. Okay, Moses sir, sorry bothering you. Yeah,
No, nothing. And it's not nothing. Apologize. I was just there's so much. It's overwhelming actually. There's so much to
Yeah,
read.
that
and
what happens. You know,
understand.
if you go through this document, you find
Yeah.
you get stuck on one of the thing which you are
Yeah.
not very sure of, or maybe it's debatable also. So it's better to discuss. That's a good thing actually.
I just kind of going through it. CRDT also is there, right? I mean, that's rightly said. OT is more of changing operations, and CRDT is about changing state.
Okay.
They make changes on local CRDT, and state is sent over the wire and merged with the state of copy. It doesn't matter how many times in which order, all copies converge. That's what CRDT is, at least at a very high level. I think so. Vinny was saying about this. Is this the same thing, Vinny, that we were saying about the Netflix problem for WebSockets?
Exactly. They have the video there actually in the YouTube.
Okay.
Yeah, they're using the Zool push as this problem actually.
Good reading material for later on, I suppose. Okay. Yep. So we are moving ahead. Let's see. Okay. So guys, just taking a consensus call. It's 11:01. Should I continue reading this part or should we start this fresh?
Yeah, fresh also we can start whatever you wish to.
This is a new topic altogether, handling right conflicts.
Okay, so it's a new one, right? So we have done with our multi-leader, isn't it?
No, it's just one part of it.
Okay.
Multileader 0.1. This is 0.2, 0.3.
And then we have replication topologies. Yeah, so that might be slightly easier. Yeah.
Yeah.
Yeah, but it's good to discuss. I don't think there's a problem, but yes, good to discuss it. Cool, guys.
Yeah,
I think. Yeah. Okay, guys. I think we'll start fresh handling right complex. Maybe tomorrow. Tomorrow.
Maybe we'll need that discussion what we have shared just now, right? So this is again about the OT and CRDT, isn't it? To some extent. So maybe can go through that document for next session.
Still pushing message, yeah.
Yeah. So
no, the QCon paper.
The one paper what you no the previous one I think you shared.
QCon.
The problem is okay, yeah, okay, my bad. This one is it? The Netflix and the WebSocket issue. This one?
I think this one.
I
This
was
one is right?
about that OT PDF what.
Okay.
Yeah. So yeah, either of it, whatever is easier. but to at least understand the basics of how things are happening in OT and this one CRDT, if it is that we are looking. So WebSockets and all that, they are very generic ones. It can be covered in many sessions, isn't it? So
Most
that is
of
not a
them
big
like
thing.
chat.
Yeah. Only OT and CRDT, those things, if you can read it, come back. So it will be easier to follow for that handling write conflicts. So we can finish this topic very quickly.
Yeah. So, I mean, at least at this statement says, right, OT is about changing operations. Just sent over the wire, concurrent operations are transformed once they are received. And this is about state. But I look at OT, I think it has quite a bit of processing happening here. Talks of consistency models. OT is to support consistency maintenance in collaborating editing systems. A number of consistency models have been proposed in the research community. OT algorithms. They are like approaches for it. CC model, CCI model, concurrency control in group-based systems, and this is concurrency management in collaborative editing system. So here they are talking about 2 consistency properties, and here they are talking about 3 consistency properties. And then comes the CSM model. So there are various models which are proposed, where they try to see how the consistency is getting managed. Yeah, I mean, and some technical stuff. This is definitely going over my head. So yeah, I mean that's interesting thing that how is this transformation exactly happening? I think it's a mathematical in nature. It's not as straightforward.
Yeah, we just want an abstract one, not so detailed.
And here it seems a table has been presented in terms of who is kind of having OT support. So there is Google Wave OT, and yeah. So yeah, I mean from an abstract perspective, that's the whole idea that it is doing operational transformation, and there's a certain model internally. But CRDT, let's talk about that. Just a second.
There's a paper where this was for the CRDT.
So, sorry, which one?
There's a good paper on this one as well, CRDTs.
CRDT, can you share it if it's available?
I think the paper you can find in the references. Yeah. In the references of maybe the DDIA also.
There also could be. I mean, there is it's like a linked list, right? One starts, then there is a several branch for it, like tree kind of thing, looks like.
Yeah.
Then again, that subtopic keeps on expanding.
Right, but to some extent, because if we just know what the high level things are, so we won't get stuck every time, we come here and we keep discussing that, so that at least will be avoided, I think.
Edible idea.
I don't know if this is the same thing.
Actually,
is it the same thing?
No. This is the main site for CRDT. You can go to that papers and see. This is also an interesting site. It has all the videos who have used the CRDT.
Yeah, I mean, anyone of you has some kind of paper available, just that.
In that website itself, it is there actually.
Is it okay?
On the right side, click the paper.
You have that
Sure.
paper, right, about CRDT. Yeah.
Papers?
Yeah, Mark Shapiro.
Yeah, click on it.
I think this is the same page that opens up.
Oh.
No.
That will be overloading. Yeah.
Next day we'll leave system design then.
No, we don't want to go that detail about conflict resolution, isn't it? So we can take that as a different topic, but something we can actually just understand.
Yeah, I mean, how is it
can move
different?
on,
Because when it
yeah.
says that it's copying the state,
Yeah.
what exactly does it?
So for
kind of
interview
mean by-
per se, yeah, we don't want to resign. Yeah.
Correct. Yeah.
So at the end of the day, it's still. I mean, we can read this. Maybe this
Yeah.
to give a bit of an idea of CRDT, right?
Sure. Yeah.
So, conflict-free replicate data type is a data structure that simplifies distributed data storage and multi-user applications. In many systems, copies of the same data needs to be stored on multiple computers in a replica. Okay. Mobile apps that store data in the local device, and that needs to sync to that data to other devices belonging to the same users, calendar and notes. Okay. Okay. And then distributed database which maintain multiple replicas of the data, the same data center at different locations. Same thing. Collaboration software such as Google Docs, Trello, Figma, and large-scale data storage processing. Also, systems need to deal with the fact that data may be concurrently modified on different replicas. Broadly speaking, there are two possible ways of dealing with such data modification: strongly consistent replication and optimistic replication. Okay, so strongly consistent replication. The replicas coordinate with each other, decide when and how to apply the modification. This approach enables strong consistency models such as serializable transactions and linearizability. However, waiting for this coordination reduces the performance of the systems. Moreover, CAP theorem tells us that it is impossible to make any data changes on a replica while it is disconnected from the rest of the system. A partition thing, network partition. Then there is optimistic replication. In this model, users may modify the data on any replica independently of any other replica, even if the replica is offline or disconnected from the others. This approach enables maximum performance and availability, but can lead to conflicts when multiple clients or users concurrently modify the same piece of data. These conflicts then need to be resolved when the replicas communicate to each other. Okay, I didn't quite get this. Users may modify the data on a replica independent of any other replica. So this is like a local storage thing that even if it's disconnected, they keep doing it. And then eventually they converge and kind of coordinate. Whereas this one, the strongly consistent approach, they coordinate and decide how to apply it. This approach enables strong consistency. But then I think they say that it reduces the performance of the system.
Yeah, so it
Because
might
they
be
are-
a single leader primary backup model, isn't it? So one server is actually in charge and control of the modifications. So it will provide the logs and all that stuff, but then it will have a performance hit, right? But then the optimistic replication is more like the multi-leader.
No, but in optimistic, once you go out of the net, right, your local disk become the master, right? I didn't understand, like users may modify the data on any replica.
Well, I think this is only the brief you talked about. Sorry, word.
Thing here is, I mean, you can ensure that master model where you update the change and you ensure that data stays up in multiple replicas as well. But that will lead to increase in latency as such, and availability and this one. But the thing here is CRDTs are based on the concept that they are basically based on two functions as such. So basically you update and merge. So they say that based upon these functions, if you ensure that the changes are propagated in any fashion, you will end up in the same state. You shouldn't miss the messages, but if you send the messages in different order, you will eventually all the machines will end up at the same state.
Oh, okay. So they use that causal dependencies using the vector clocks, version clock, something like that, right?
No, here it's similar, but not exactly. So they call, so when you're doing modifications on multiple machines simultaneously, you will end up with conflicts, right? So you need to do a merge conflict thing, right? So there's a merge function that is associated with every CRDT data structure as such, how the merge should happen. And those has some good mathematical property. So basically they say that it needs to be associative and I couldn't remember that operation of A, comma A is still A itself. So basically there are some mathematical properties on which this CRDT has been developed, which ensures that even if you send these changes in different fashion, they will end up in this same state eventually. Let's say there's a count, there's a grow. I will giving you one example. There's a counter that can go up or down. So it is actually divided into two counters internally. One is a one takes care of noting down all the increases, and one takes care of noting down all the decreases. So when you make a decrease, it should always go down. When you make it increase, it should always go up. But the counter values difference of the addition of these two difference of these two values. So so when you when all machines receive all these messages, you will end up with the same value. Let's say there are two machines in A and B. You add 1 to A and you add the similar increment to B as well. Similar, another person incremented the same value by 1 in B as well. Now, even if you merge it, if a human merges it, he might think that both are of the same value. But if you pass the same messages to both of them, A's increment to B, B's increment to A, it will eventually end up at 2.
Okay.
Yeah. So there are certain data structures with those mathematical properties, idempotency and associativity. It helps to understand the mathematics, why this optimistic replication and is selected as such. It can't be this is not a one size fit all, but it is applicable to majority of the situations. Every use case has some good data structures.
So a lot of mathematics, but the real applications of mathematics are being used somewhere, and they work perfectly fine.
Yeah.
Okay, cool.
Yeah.
So I think that will be too hard to understand, but whatever best we can. So we'll go through that.
Yeah, any noble soul who is very kind, this is a paper that actually talks about it. I think it's a good starting point, which has approaches like they have mentioned here 3 approaches. Need to read about it. It's like add wins, remove wins, and last writer wins. And then there is the counter, which I think so Uday was saying maintains a counter over here for the read and write and update operation.
So this is a 20-page
Overall,
document.
it's
Yeah, and it's too much of detail.
yeah,
To high level,
20 page
if
document,
someone
yeah.
can read it, it's fine because all are novel source, no problem.
Yeah.
Let's go through as much as possible, everyone, whoever catches, and then we can discuss and try to convert it, So it should be okay. Yep. But this is a good one. Okay. I also have it marked it. So let me see how much I can do.
And they have mentioned example-wise distributed systems and replicated systems, storage systems. Two groups of systems where it is applicable. Storage systems that provide CRDT as a data model, an application that embeds CRDT to maintain the internal data. So, but good. I mean, this is good stuff.
It is absolutely.
React, React, and backup.
Yeah.
I didn't know about CRDT or OT for that matter before. Maybe this conversation has given light to that area, which at least gives me at least a one-liner understanding of what OT is and what CRDT is. Implementation-wise, it's completely different, big universe in itself. But still, good to know things.